question 5, there's a lot of marks, there's a lot of work to do here. So just do take your time and try each bit slowly. First thing is just sketching a graph. So let's draw ourselves an axis here. And thinking about where is it going to cross the axis? Well, it's going to cross the axis when x is 0. That will make x is 0, y is 0. And the other point that's going to be interesting is when x is 2. Let's stick a 2 in there. It's not going to cross the axis at any other point. It's not going to cross the y-axis at any other point. And it's a cubic. Now, cubics start down low. It's going to come up here. Now, it's then going to just touch that point there and then go off. It can't cross there because it can't come back again. So it just touches there. So there's the graph. And that's worth 3 marks to start with. Then, just for 1 mark, we've got to multiply this out. It seems like a lot of work for just 1 mark, but just multiply out this bracket here. So we got x squared minus 4x plus 4. That needs to be times by x. So when we times all of that by x, we get x cubed minus 4x squared plus 4x equals 3. Take away the 3 from both sides to get that. So we've now got this being defined as p of x, the polynomial. And we're now going to try and use the remainder theorem. So to use the remainder theorem, I need to think what number makes this 0 or minus 1 and find out, well, what is p of minus 1? Sticking in minus 1 into the equation, I get minus 1 cubed minus 4 lots of minus 1 squared plus 4 lots of minus 1, take away 3. Now, figuring all of that out, they all turn now to be negative, so we've got minus 1, minus 4, minus another 4, minus 3, minus 12. So the remainder there is minus 12. Well, the next part says use the factor theorem to show that this is a factor. Same idea. This time what makes that 0 is 3. So we're finding what p of 3 is. And that gives us 3 cubed minus 4 lots of 3 squared plus 4 lots of 3 minus 3. Loads of 3's here then. And that works out to be 0. Now, because it's 0, the factor theorem says that it's a factor. So make sure you write that. Therefore, x minus 3 is a factor. Now, the next bit is to actually do the division. We need to divide this big long cubic by the x minus 3 to get the quadratic. Now I do my long divisions in box method, but there's many other equally valid methods. And what do we want? We want an x cubed here, so we have to start with an x squared. Well, that x squared gives me 3x squareds there. I don't want 3x squareds, I want minus 4x squareds. So I need to take another x squared here. That means I'm going to need a minus x there. Minus x times 3 gives me 3x's. I don't want 3x's, I want 4x's. So I need another x there. That means I need a plus 1 there. 1 times minus 3 is minus 3. Good, that's what we wanted it to be, because that's what the question said at the beginning. So this tells us that the big long cubic that we were looking at is actually the same as x minus 3 times by x squared minus x plus 1. Now it's telling us that this has only got one real solution. Well, that's clear that we've got a solution here when an x is equal to 3. So that's the, but showing it's only got one solution really means that we need to show that this has got no solutions. Well, to show that it's got no solutions, we need to use the b squared minus 4ac. b squared minus 4ac is equal to minus 1 squared minus 4 lots of 1 lots of 1. That's 1, take away 4, which is minus 3. It's negative. It's negative, and so that implies that there are no real solutions to that part there. That's what they were asking us to do.